Okay, so this week tutorial is on concrete mix design. So what do we mean by concrete mix design?
Talking about like slump, NPA, that kind of stuff. Like,
Yes, when we know the slump and the strength. So strength is what we need in the final hardened concrete. Slump is the workability measure of a workability. So that gives us a property of fresh concrete. So those, depending on the slump we need and also the strength we need, we should be able to select the right materials and also the right proportion. That process, selecting the right material and finding the right proportions, that process we call the concrete mix design. Is that clear? Okay, so in a concrete mix, what do we have? Mainly we have aggregates. So when we were discussing about the aggregates, we discussed about it. 85% or 80% is aggregates. So it has, when we consider the aggregates, that can be coarse or fine. Am I right? And also we have cement and water to bond the aggregates together. And also we add admixtures to improve properties. And also there are, in some situations, we have to have air, purposely added air. We call that air entrained concrete. So accidental air is the air which is trapped in the concrete when we do mixing. We need to get rid of the accidental air. We do that by vibrating and compacting. However, in some situations, we need to purposely add air. We call them air entrained concrete. So what are the situations where we need to have air entrained concrete? Any idea? We discussed something last week as well regarding sulfate reaction with concrete. So when the sulfate reacting with concrete, if we do a concrete in a sulfate environment, that reaction makes the concrete swell and expand. So in that case, we need to have that space provided to expand, otherwise the concrete will crack, isn't it? And also in a freezing environment, when water freezes, what will happen? It will expand. The volume of ice is more than the volume of water. So in the freezing environment, like, when freezing and thawing, we need to have entrained air, giving that space to water to expand when it becomes ice. Does that make sense? And also you should have heard of a permeable concrete, where we let the water to infiltrate through the concrete. What's that? No, fine. And also sometimes we need to add air as well. So the voids are there so that water can infiltrate. So there are situations where we need to purposely add air. So we have some admixtures to do that process, and you should have learned it in the theory. Okay, so as we have discussed, selecting the suitable ingredients and determining their relative quantities, that process we call the concrete mixing process. And in the concrete mix, as we have already discussed, we need to know how much of cement needed, how much of water, how much of coarse aggregate, and how much of fines we need. And also in some situations, we have air. So we need to know how much from each we need. So that's what we are going to do today in the first question. So we need to select the ingredients in a way that we will get the properties in the hardened concrete and also the properties in the fresh concrete. So in the hardened concrete, if you look at the hardened concrete, what are the properties we are looking at? Mainly the strength and also the durability, shrinkage, skid resistance. So they are the properties that we are looking at for hardened concrete. And also when you look at the fresh concrete, workability, compaction, curing. Workability means what? How easy to work with. If you have more water in the concrete, it is more easy to work with. However, if you have more water, that will reduce the strength. So in that case, we have to have the right amount of water, right amount of workability. And also sometimes we discussed last week as well, we can have super plasticizers and plasticizers admixtures to improve the workability. So that's why we need to find the right materials and also the right proportions. Okay, so that's the summary of what you have done in the lecture. There are more things. Please go through the lecture. But those information will be enough for you to do the questions now. Okay, in the first question, we need to do a concrete mix design for this particular application. Concrete is required for a foundation where it will be severely exposed to sulfate. So when we see these things, we need to highlight them. So if it is a severely exposed environment, what should be our concrete? Is it an air entrained concrete where we purposely add air, or it should be a non-air entrained concrete? Air entrained. So we know that. The average strength. So we know the strength should be 34.5 and the slump should be 80 to 100. So these are the two requirements in hardened concrete and the fresh concrete. So these are our requirements. So if we know that, now we are going to use that information and select the right proportions of different ingredients. And they have given us some information about the coarse aggregate. So they are saying the available coarse aggregate has a maximum size of 40. So maximum size is given. The dry rodded bulk density is 1,600 kilograms per meter cube. What do we mean by this? Dry means what? Yes, without water. So if we take a sample of aggregates and if we oven dried it, it will become dried aggregate. So in that, if we dried it, and rodded means what? Yes, you compacted it. So it's normally in concrete, do we compact, or else aggregates are staying with space between the aggregates, isn't it? So the cement or the concrete, the cement paste will bond the aggregates together. So we need to have space between aggregates. We don't have rodded aggregates, but they are saying the dry rodded bulk density of the aggregates available in the market, that is 1,600. Okay, and they are saying specific gravity, surface saturated dry condition, it is 2.68. Water absorption is 0.5% and the moisture content is 2%. So what do we mean by those two moisture contents? Absorption is 0.5 and moisture content is 2%. What's the difference between that? Absorption means we discussed when we did the aggregates. Aggregates has tiny pores. So the water inside the pores, they can't contribute in the hydration process. So that percentage of water, 0.5% of water in the aggregates is inside the pores and it can't contribute to the hydration process. Hydration means the reaction between the cement and the water. And out of this 2%, 0.5 is inside the pores and the other 1.5% can be contributed to the hydration process. Is that clear? Next part. It is related to the fine aggregates. So fine aggregate has bulk specific gravity of 2.65. Absorption is 0.7%. And the total moisture content is 6%. That means out of this 6%, 0.7% is absorbed and 5.3% can be contributed to the hydration process. Does that make sense? Okay. And here it says fineness modulus. We discussed fineness modulus last week, did we? So you know what is it. And now we have to use we calculated it. It is a process of calculating. It gives you how much of fine aggregates are in that. How much of that? So the aggregate confirm of the grading requirement, use the ACI method to find the relative proportions of. So we need to do the concrete mix designs using the ACI method. There are different methods to do the concrete mix design. American Concrete Institute method, British method, and there is a rapid method as well. So there are different methods. So they are asking us to use the ACI method. You only learned that. You haven't learned the British method. But if you want to, you can search and find those methods as well. So British method is from UK and the rapid method is from India. Okay, now we are going to use this information and we are going to find do the concrete mix design. Okay, so here these are the things, important things. Okay, they have given us some tables. Now we need to, there are 10 steps in the ACI method. And we are not going to like mention this step is this. When you do it, you will figure out. We are following the steps, even knowing that we are following the steps. You don't have to you don't have to remember the steps. However, we are following those steps when we are doing this. So they have given us some tables. So let's see what we can get from this table. So this table, if we know the sulfate exposure, we will be able to find out the maximum water to cement ratio, and also the cement type, and also the minimum compressive strength. Can we find those? Do we know the sulfate exposure? Is it moderate, severe, very severe, or negligible? What do we have? Severe, it was in the question. Yes, so it is severe. So the cement type is 5, and maximum water to cement ratio is 0.45, and the minimum compressive strength should be 31. So we are looking for something with 34 megapascals. Am I right? That's what we have in the question. So this one is anyway satisfying because we are going to design a concrete mix with more than 31 megapascals. Okay, so these are the things that we can find from the first table. Second table, what can we find from the second table? What can we find? If we again know the sulfate exposure, we will be able to find out the minimum cement content. Am I right? And also the maximum water to cement ratio, we can find that. So is it slightly aggressive, moderately aggressive, or highly aggressive? We have a severe exposure, so that will be, we can't say moderate or slightly. So we'll go with the highly aggressive. So maximum water to cement ratio is 0.45 and the minimum cement content is 360 kilograms. We design for a cubic meter. Okay, so we find the amounts of all these amounts for 1 cubic meter. Any question up to here? Next one, what can we find from this? Recommended air content you can find if you know the maximum size of aggregates and the severity. So we have a severe exposure to sulfate, and we know the maximum size of aggregate with what was that? 40. So that means we need to have 5.5% of air in our concrete. Are we good? Okay, next one. What can we find from this? If we know whether we are designing for AIM trained or non-AIM trained, we can find out the effective water to cement ratio, isn't it? So effective water to cement ratio, if we know the strength of our concrete, hardened concrete. So what is the strength that we were looking for? 34.5, and it is AIM trained concrete. So the effective water to cement ratio is 0.4. Is that right? When you go to the next table, what we have, again, depending on whether we are looking at AIM trained or non-AIM trained. So here we are looking at AIM trained. Depending on the slump, our slump is 80 to 100. Am I right? And if we know the maximum aggregate size, which is 40 in our case, we will be able to find out the water content, isn't it? So this is for water content. And also we can find out the amount of AI entrainment we need to have, which we already found as 5.5%. Here also it is mentioned as 5.5%. Any question? No questions?
How do you know if the age, that is age,
Because whenever we have sulfate, so you sulfate, then we found it in one of the tables here. If you don't know, even if you blindly doing it, still you can, you know, we need AI trained here. Severely affected, so here in the previous. So this one, not this one. Which one? Yes, here. If it is severely affected, then we need to have air, 5.5% of air. Concrete, when it reacts with sulfate, it expands. So when it is expanding, we should provide that space to expand, otherwise the concrete will crack. So we have to, that's why we are purposely adding air. So when we purposely adding air, we call that air entrainment. That's our air entrained concrete. Okay, so we did this, right? Yes. Okay, what we can find from this table? If we know the maximum size of aggregates, and if we know the fineness modulus, it was 2.8, isn't it? Maximum size was 40. We will be able to find out the dry bulk volume of rodded concrete, rodded coarse aggregate per unit volume of concrete. That means, if you can remember, dry bulk density of coarse aggregate, dry rodded bulk density of coarse aggregate, that was 1,600. Do you remember that from the question? And this is in dry rodded bulk. Out of this, only 71% is in the concrete. So not 100%. So only 71% of 1,600 kilograms will be in the concrete mix. Does that make sense? Okay. Next one. Depending on whether we are looking at the air entrained concrete or non-air entrained concrete and the maximum size of aggregate, which is 40 in our case, we can find out the weight of fresh concrete in a cubic meter. So when you add all together, we need to have 2,320 kilograms in a cubic meter. When you add coarse aggregate, fine aggregate, water, and cement together, we don't weigh the air. The rest of the things should be 2,370 kilograms. Sorry, 2,320 kilograms. Are we good? Any question? No questions? Okay. So that's all from the tables. So I have summarized everything here. So from these tables, we have found these values, which are in our right-hand side. So you can see from table 1, we found this too, ASTM cement type and the maximum water to cement ratio. In the second table, we found the maximum water to cement ratio and the minimum cement content. Then recommended total air content, 5.5%, and effective water to cement ratio, water content, the percentage of dry rodded bulk aggregates in the concrete mix, and also the total weight of the fresh concrete. So these ones are from the tables and these ones are from the question. Any question up to here? Okay, now let's. We discussed about different types of cement last week. So we categorize, in the ASTM system, they have given you cement type 4 is this, cement type 5 is this. You can find out what are there. So they have different values, like, you know, in the last week, do you remember we discussed about different types of cement? So in the ASTM system, they have given numbers for these different types of cement. So we discussed about the shrinkage resistance. We discussed about what else? Low heat cement. So likewise, there are different types of cement. So ACM5 is a kind of cement. I can't remember what that is, but if you type in Google, you will be able to find out what is that cement. Okay, now do we know anything straight away from these numbers? So we are going to find out these things. So AR percentage is 5.5. We don't worry about that one for finding the rest. So do we know anything? Do we know the amount of cement? Do we know the amount of coarse aggregates? Water. So we should be able to find them. Am I right? Water is known, 160. Do we know the water? This is 160 kilograms. Am I right? And the coarse aggregate, if you look at, before that, let's take the cement. Do we know minimum cement content should be 360, but it can be more than that. Now we need to find the right amount. Effective water to cement ratio is 0.4. Maximum water to cement ratio is 0.45. So if we already know the water content. If we know the right water to cement ratio, we will be able to find the cement content. So what is the right water to cement ratio?
Ratio.
Yes, water to cement ratio is 0.4 or 0.45 or what? 0.4. That is the effective value. And if we select the 0.4, that will satisfy the other two as well. That is the maximum can be 0.45. But when we select the 0.4, that will satisfy the other condition as well. So now you know water content is 160. So you can find the cement content. Can you guys find me the cement content? Yes, 400 kilograms. So water is 160. Okay, now any question up to here? No. Okay, so now we know coarse aggregate, dry roded bulk density of coarse aggregate is known. Is that right? So we know this. And we know this one as well. Can you tell me dry bulk density of coarse aggregate? Not the rodded part. So rodded means we compacted. So how much of coarse aggregates that we have here? Out of the 1,600, 71%. Am I right? So how much is that? Yes, 1,136 kilograms. Am I right? But this is dried amount. Am I right? Oven dried, isn't it? So we need, do we have coarse aggregates in the dry condition in the market? When we consider the coarse aggregate available in the market, are they dried? No. So how much of water in this one? 0.5 is absorbed. 2% is the total. Okay, so let's first find the total of the so this one. This is the amount of dry coarse aggregates that we have in the concrete mix. If you add the absorbed water, how much of aggregates? What is the weight of the coarse aggregate with absorbed water? How can you find it? Yes, so this is the amount of absorbed water. Am I right? 0.5%. Isn't it? So if you add this to 1,136, that will give you the weight of the coarse aggregates with absorbed water. How much is that? Yes. Roughly 1,141. Okay, now are we able to find we found three things now: coarse aggregate, cement, and water. Can we find the fine aggregates? How? We got the total of the fresh concrete. So if you minus these three things from that, you will get the weight of fine aggregates. Am I right? How much of fine aggregates are there? What do you get?
119.
Yes, 619 kilograms. So do you all get that? Up to here, any question? No questions? No questions? Okay.
We're at the end, is there no air in this place? Like,
What's that? Sorry, I didn't get you. What
oh,
is that?
the air.
Yeah, when we consider the weight, we don't measure the weight of air, isn't it? So air is volume percent of 5.5. That we can add an air entrainment, an admixture, and we can make that. The air entrained, and the difference between air entrained air and accidental air is accidental air means when we mix concrete together, normally it is with air. So what we do, we don't have to have that lump air here and there in the concrete. What we do to get rid of that, we vibrate or we compact it, isn't it? So to get rid of the accidental air. But this air, entrained air concrete, they are evenly distributed throughout the concrete because we are purposely doing it we follow the process to do it using an admixture which forms the air. Okay, so that we don't consider for the weight here. However, why any question? So what's the issue? We haven't finished. We need to do a water correction. What is the water correction? So that is this. So coarse aggregate is coming with 2% of water. 0.5% is absorbed, but however, the difference between these two, which is 1.5%, is there, which is surface water, which can be contributed to the hydration process, isn't it? The water, it doesn't matter whether it is additionally added or whether it is coming with aggregates. If it can be contributed to the hydration, it will be doing that, isn't it? So there is, if you consider 1,141 kilograms of coarse aggregate, out of this, if you want to find out how much of water coming with that aggregate, which can be contributed to the hydration process, that is 1.5%. Agree or not? So this much of water is coming with coarse aggregate, which can be contributed to the hydration process. Similarly, if you consider the fine aggregates, 619, 5.3%, isn't it? 6%, 0.7%. So 5.3, the difference is. This much of water is coming with fine aggregates, which can be contributed to the hydration process. So if you add these two together, how much it is?
So the fine aggregates, it's 32.8.
Okay. 17 point something, isn't it?
And then you get the other one, 72.
Yes, so altogether 50 kilograms of water is coming with aggregates. Am I right? Now tell me, if we have that 50 already coming with aggregates and 160 additionally adding, what will happen? Do we have the right amount of water or excess water? Excess water. So 50 kilograms of water is excess if we add 160. So we are not going to add 160. Instead of, we are adding 110 kilograms of water. Is that make sense? Okay. So with this, we are finishing 9 steps. So that is the 10th, what is the 10th step in the ACI method? If you don't write it, you will lose marks. What is the last step? You do a trial mix with these quantities and you check the strength and the slump. So strength should be what? 34.5 and slump should be 80 to 100. So you check it. That is the trial 880. That is your last step. Any question?
Yeah, you mean check that as in the lab before everything, or you could check it on the table?
No, you do it in the lab.
Yeah.
You do it in the lab. Slump test.
You have to always write down check.
Yes, you need to write down, do a trial mix and check the slump and the strength. Oh, good. Any questions? Okay, let's move to the second question then, if you don't have any question regarding the first one. So in the second question, they are saying the design engineer specifies a concrete strength of 31 megapascals. Determine the required average compressive strength. So we are looking at two strengths. Specified concrete strength, we use F-C as the abbreviation, and required average compressive strength, we use F-CR for that. So what is the difference between these two? Specified strength is what we actually need for our project. But if we ask a plant to make a concrete mixing plant to ask a concrete mix with 31 megapascals, we can't say 100% that we get 31 megapascals. So we need to mention a higher value than that. For example, let's say we can ask them to make 40 megapascals, or maybe if we are not sure, we ask to make 50 megapascals. So we have to ask more than which is specified to make sure that we get at least this one. So how we can find out what is this value, the required average value? If we just say for the safe side, let's say 60, what will happen? Our concrete is not economical, isn't it? So no point, if we need 31 megapascals, no point of over designing it. So it's concrete mix need to be economical as well. So there is a method to find the required average strength. So this required average strength is depend on few things. One is how many number of tests that plant has done. And also the other thing is the standard deviation of the test results. So I hope you know what is standard deviation, because now you guys are in second year. And you have this in your lecture notes, this one, that is standard deviation. You can go through the notes. Okay, so we have 3 set of equations. The first equation set is this. If the number of tests are less than 15, we just use this table and we can find the required average strength. For example, let's say in our question, we need 31 megapascals, isn't it? And let's say we have a plant with 10 tests. So can you tell me what is this is our F dash C. So can you find me the required average strength if you have 10 tests and we already know the megapascal F dash C is 31. So can you tell me what is F dash CR? How did you do that? You just use this one because your strength is 31 megapascal. So it's easy. So when the number of tests are less than 15, we use this table to do it. When the number of tests are between 15 and 30, we use this set of equations. Okay, you don't need to remember equations. Equations will be given to you. You should know how to do it. So here you can find F dash CR if you know few things. If you need to know this one, do we know this? Yes, we do. It is 31. And also S dash. It is not the standard deviation. It is standard deviation times a factor. This factor can be found using this table depending on the number of tests. For example, if you have 20 number of tests, if the plant has done 20 number of tests, you multiply your standard deviation by 1.08 to find the S dash, and you are going to use that S dash to find the F dash CR. Does that make sense? But in our question, we'll do the question. We are going to use this equations in our question, and we have few more equations. So this one, we have another set of equations. So depending on your F dash C, you can either select the top equation or the bottom equation. In our case, we have to use which one? Top one. So you use this equation, and also we need to use this equation. We use both the equations, and we have to select the higher value or the lower value. For example, let's say this one, I get, if I use this one, I get 34. When I use this one, I get 36 megapascals. Which one I need to consider? Higher value. So I say F dash CR should be 36 megapascal. Why the higher value? For the safe side, we use the higher value. Does that make sense? Okay. And the third set of equations are when the number of tests are more than 30, you have the same equation, but instead of S dash, here we are straight away substituting the standard deviation. You don't have a table like this to use a factor to multiply your standard deviation. Here, you just substitute the standard deviation. Does that make sense? Okay, now you should be able to do this question by yourself. Okay. So the first one, they say you have a standard deviation of 3.6 and number of tests are 17. So these are the equations that we have. What is the factor? So you need to use these two equations. Am I right? Not the bottom one, because our specified strength is 31 megapascal. So now we need to use this table to find the factor. So we have 17 number of tests. So it is between these two. 17 is somewhere here. So how do you find this factor? Yes, so you interpolate it, but you need to do it in the proper way. How do we do it in the proper way? You can't just guess the middle number and get it. You have done it in maths. So when it is 20, see, when the number of tests are 20, the factor is 1.08. When the number of tests are 15, the factor is 1.16. So if I plot it, it's like this. When the number of tests are 20, the factor is 1.08. When the number of tests are 15, the factor is 1.16. So we need to find for this, this 17, isn't it? So how do we do it? Yes, so you find, you consider these two. If you consider this big triangle, you can write rise over the run. Same slope, isn't it? And also you can write the rise over the run considering the small triangle here. Both you can equal them, isn't it? So that means if you consider the rise over the run for the big triangle, that will be 1.16 minus 1.08, that is rise, isn't it? Run will be 20 minus 15, isn't it? If you look at the small triangle, this one here, I just take this as OL's factor F. How can I write it? F minus 1.08 divided by 20 minus 17, isn't it? So I can find F from this one. Can I give you a few minutes for you to find the F? Can you guys find me F? What is it? 1.13, I think.
Yeah.
Yes, so let's take it as 1.13. So what is your S dash in this case now? S dash is what? F times the standard deviation. F is 1.13 times 3.6. Does that make sense? Now, will you be able to find me the F dash CR using this equation? What do you get? What do you get for this one? Okay, 36.5 megapascals. How about using next one? Do you all get the same? This is what I got. Okay, which one to select? Higher one, which is 37.1. Do we have any question? No questions. Can you do the next one now? It is easy because you don't have to find a factor. You have the standard deviation. So can you find me the two values and tell me which one to use? So here we have more than 30 tests. So we use that particular set of equations to do that. Am I right? In the previous one, we used different set of equations. Am I right? So they are different. I showed you. Depending on number of tests and the yes, depending on the number of tests, the equations, there are three sets. So this is when the number of tests are less than 15. This is between 15 and 30. This is for more than 30. So now in the second and third, we have more than 30 tests. So that's why we are going to do with the 30 tests, more than 30 tests. I'll give you a few minutes. What you get?
And then incorporate the line for the first one, like, what we have 34.21 for the first one, and 33.9 for the second.
Yes. So which one we select? First one. How about the next one? Can you do for the third one? Now the standard deviation is 3.8. What you get?
36.19 for the first one, and 33.8.
Okay, which one we use? Second one. So we can't, just by looking at the equation, we can't say first one or the second one. We have to put the values and see which one to, which value it should be. Are we good? Any question? Okay. So we have one more question. We have time. So if we summarize, if you go with the first plant, we need to ask the plant to make the concrete with a strength of 37.1 megapascals. If you go with the second plant, you need to tell the plant to make 34.2 megapascals. If you go with the third plant, you have to ask them to make 36.4 megapascals. Are we good? Okay. So the next question, last question. What factors may affect the workability of fresh concrete? Workability is how easy to work with. So if the concrete is not workable, then you won't be able to pour to the right, pour correctly to the formwork. But if you make the concrete more workable than required, then it will, your strength will get affected. So you need to select the right workability. So what are the factors affecting the workability? Water content, water to cement ratio. What else? Slump is the indication of the, yes, how we measure the workability. There are other different tests as well to measure this workability. Slump is one method. Aggregate size, shape, and the angularity and all of those things. Because if you have rounded aggregates, they are more easy to mix. But if you have, like, irregular shapes, it will be harder to work with. And when you have smaller particles, easy, bigger particle may be hard. And also the, what's that?
No, sorry, I was just saying, like, the factor in this question, the weather and stuff, or is it more just like
Yes, specifically for the concrete, yes. And the aggregate to cement ratio, degree of air entrainment. Degree of air entrainment, if you have more air, it is easy to mix. Am I right? Have you done a cakes mixing? So when you have air, it's easy to mix. If you beat eggs, like, it will get bubbled and it is easier than mixing. So if you have more air, it is easy to mix. How about admixtures? There are some admixtures which improve the workability. We purposely adding them to improve the workability without compromising the strength. They we call the plasticizers and super plasticizers. They are like lubricants. So they are tiny, like, different materials that they make the concrete more workable. And also there are some other admixtures we add to improve other properties can affect the workability. So we need admixtures also affect the workability of concrete. Are we good? Okay. So as a summary, like, when when we make bread or cake, you use the same ingredients, flour, butter, sugar, eggs. But depending on the amount, relative amounts, you get two different tastes, and isn't it? So likewise in the concrete also, depending on the amount of relative ingredients, the properties will be different. So it's very important to find the right amounts of the relative ingredients, and also the selecting right ingredients. We discuss about the cement, different types of cement last week. So we should be able to select the right cement depending on our requirements. Next week, you will discuss about the bitumen, I think. Is that right? Again, we need to select the right bitumen for flexible pavements. Here we are discussing about the rigid pavements. So it's an interesting subject. We will be, yeah, that's all for today, but next week we will discuss about bitumen.